Hi. Continuing on our Wi-Fi 6 journey, I'd like to summarize a few things related to multi-user transmissions. Okay, these are not so obvious and these are not some mainstream ideas, but maybe just something which has to be kept in mind deep down. My name is Shrikant and I'm with NanoCell Networks. So Wi-Fi 6 allows an access point to send transmissions simultaneously to more than one client by using this feature called an MU-PPDU, a multi-user PPDU. Of course, it can be MU-MIMO or OFDMA or even a combination of both. Okay, and there are various related things. OFDMA, of course, is sort of mandatorily present in all Wi-Fi 6 products, and so on. Now, what flexibility does the AP have in terms of addressing a bandwidth? Can it, send as it wishes? Yes and no, and that's what we want to try and summarize. Okay. For example, uh, in a non-DFS channel, if the base station, or rather the access point, I should say, is using a bandwidth of, let's say, 20 megahertz, just to start with, a 20 meg PPDU, okay, then it has to occupy at least this many subcarriers. Okay, so which means you can't just send a 20 meg PPDU and just send 226 RU allocations. That's not allowed. Okay, so you need to occupy at least 4 into 26. Okay, it need not be 4 separate 26. It could be, for example, a 106 tone allocation to one user. That's absolutely fine. Okay, remember that if you are having more than 20 megahertz, there is always the primary 20 megahertz in which you need to allocate at least one RU. Okay, so that's also something to keep in mind. So if you take 40 megahertz, remember that 40 megahertz means you would put this number as 2 times. So which means you have to occupy 2 times 104 tones, and you have to occupy at least one RU in your primary 20 megahertz. Things get a little bit more interesting in DFS channels, because remember that in DFS channels, other stations might trigger a DFS when they see very narrow allocations. A 26 tone RU allocation in a 20 meg channel could trigger a DFS alert for somebody else. So you need to be extremely careful. So there is an absolute minimum in any DFS pieces. And not only that, if there are legacy, you can say BSS, which don't understand all of these OFDMA tricks, etc., then you have to be extremely, careful. In fact, so much so that there is a separate field for new generation 11AX stations where they can indicate this kind of a narrow band intolerance, which would mean that there has to be, at least some minimum allocation. Okay, so these are some things relevant for the downlink. And of course, the motivation comes from the fact that there has to be at least some minimum allocation, and of course, in DFS, a little bit of an extra care so that you don't incidentally trigger DFS for some other BSS. Okay, remember, you can leave a complete 20 meg blank according to the preamble puncturing rules. That's allowed. What about uplink TBPPDU? Here you can see an example where an APS allocated some very narrow sort of allocations. And this is precisely one of the triggers where somebody else close to these stations could be looking at these transmissions. And if it was a DFS channel, it could trigger a DFS. So you don't want that. So in uplink, we go one step stronger, that if it is a DFS channel, then you might sometimes have to ban triggering, which means no trigger based transmissions or TBPPDUs, okay, because of this DFS problem. Again, you infer about whether you can do triggering or not, either directly through that intolerant bit setting, narrowband intolerant bit setting, or indirectly when you observe some legacy or some station which is not capable of signaling that. Okay. So this is where we are with respect to some freedom with respect to OFDMA. Okay. So I hope that gave you some insight into various things that an AP has to keep in mind. For more information, please do take a look at our websites, and we have more detailed courses upcoming as a part of Wi-Fi Now Academy. Thank you.